There, everyone. We're going to be working on graphing exponential functions in this video today, and we've been working a lot with functions before this point, but usually functions were lines. But functions, by definition, if we go back to what it used to be, is every input has exactly one output. And the reason why that's important is that we can make a table of values pretty easily with functions. And so since we are dealing with functions, we're going to be using tables a lot in this video. But exponential is different than linear because linear has the same rate of growth every time. We call that the slope. But exponential grows more and more rapidly. And a lot of times you'll hear the word exponentially kind of just in conversation, that it grows exponentially, which means it gets bigger and bigger and bigger, quicker and quicker. So let's get into it. So when we're talking about growing exponentially, over here on the left, we have 2 to the first power, which is just equal to 2. 2 to the second power would be 2 times 2, which is 4. So far, the jump is pretty consistent. But 2 cubed is 4 times 2, which is 8. This would be 16, and finally 32. So here we grew by a factor of 2. Here we added 4. We added 8. And we added 16. And every time we raise our exponent 1, it makes that factor increase a little bit more every time. Now on the left, we have it for if we're getting smaller, and the same pattern ends up being true as well. 5 to the first is just 5. 5 to the 0, if we remember from exponents, anything raised to the 0th power is just 1. So from here to here, we divided by 5. So 5 to the negative first, that means the fraction 1/5. Once again, we divided by 5. So then here would be 1/25, 5 times smaller. And then 1 to the 1/25, 5 times smaller again. And so when we're talking about growing exponentially, we're not adding 2 each time. We're usually going to be multiplying or dividing by some factor to make that rate of growth steeper. So let's solve our first exponential function here on the left. And because this is a function, the first thing that we are going to do is we're going to make a table of values. And if you come up to me right now and say, because exponential functions are functions, the best way to solve them is with a table of values, you can get 5 SPs. So to solve this problem, our table of values, my 5 favorite values still work here. -2, -1, 0, 1, and 2. And once again, we're just going to plug these into the exponential function and see what our output is. So if I do 3 to the -2nd power, negative exponents mean fractions. So that'd be 1/9, because 3 squared is 9. So that's 1/9. So if I go to -2 here on the line, 1/9 is just barely above the line, so it's somewhere right about there. For 1/3, I go 3 to the -1st, which is 1/3 at -1 here. So we're getting a little bit bigger, but we're definitely still not there yet. Now 0, anything raised to the 0th power is equal to 1 whole, right there. And now we're starting to see a little bit of a curve happening right here. 3 to the first power is equal to just 3 here. Now we're getting that steeper rate of growth. And finally 2 ends up being 9 because 3 squared is equal to 9. And now we're seeing a non-line. Now it's really hard for me to graph this on my bamboo board, so don't make too much fun of me about this here. So it goes up like this infinitely, and then right here. Now what's important right here is it does not dip below this line. It's technically, and it's hard for me to draw this, but technically we have basically a straight line that's coming down here, which means it can never get below 0. because no matter what exponent I put up here, it's going to create a fraction, not a negative number. Therefore, something that's really important with exponential functions is that you are always going to have a bottom of where it can't reach. So when we talk about domain and range, which we've talked about before, domains comes first in the alphabet, just like X comes before Y in the alphabet. So our domain can be any X value. We can pick any X value on this line. So we're going to say all real numbers. But our range cannot go below this line, because as we see, we're going to go 1/9, 1/27, 1/81. It's always going to be just barely above 0. So the way that we can write this is we can say all real numbers above 0. Or if you remember, we can write it as 0 to infinity. And that sideways 8 there just means infinity. Okay, so let's do one that's a little bit tougher here. Once again, we're going to make our table of values. Okay. And I always like to pick -2, -1, 0, 1, and 2. Now, I'll tell you, you can pick any numbers you want, but -1, -2, 0, 1, and 2 are the 5 smallest non-decimal numbers, so that's pretty nice there. So now, because we have kind of a crazier problem, I'm going to start at 0. Okay, so I'm going to do 2 to the 0th power minus 4. Now, 2 to the 0th power, that's just 1. And 1 minus 4 gives me -3. Okay? 1 here, that's 2 to the 1st power minus 4. 2 to the 1st, that's equal to 2. 2 minus 4, that's -2. So I do have some negative numbers here, but that's from this subtraction at the end. This number in front still can't be 0. 2 to the 2nd, that's 4. 4 minus 4, that's 0. So we're getting our rate of growth here. Now let's look at our negatives over here on the side. 2 to the -1st minus 4. This is where some people aren't going to like this very much. This is equal to 1/2 minus 4. It's going to be -3.5. You can write that as a decimal if you want to. And then 2 to the -2nd power minus 4. This right here is 1/4 minus 4. So that'd be like 4 minus a fourth. So -3 3/4, 3 7/500. So I notice that it's approaching -4, but it's never going to reach -4, which means our range, which once again is our y's, is going to be all real numbers above -4, or you could write this as -4 to infinity. Okay, so now let's graph it. So -2, and then -3 3/4 is down here. -1, -3.5 is right there. 0, -3 is right there. 1, -2 is right here. And 2 zeros right here. So we're starting to kind of see our line. Now I'm going to kind of cheat a little bit since it's hard to graph here. So I'm going to draw my line up to this point. So I know that it's going to get closer and closer and closer to -4, but never reach it. And then my exponential graph is going to grow up like this. Oofta, that's really tough. So that's just the beginning of graphing exponential functions. The retake has a few more examples there for you, but the biggest thing to remember is it's not linear, and you are always going to be able to pick any domain. Where the difficulty is going to be is that range, that there's going to be a floor every time, and you got to figure out what that is. As always, if you have any questions, please let me know.